Hi, welcome back. The problem today is about a logarithmic equation that contains the sin x and cos x. Now, let's get started. We have log base sin x of cos x equal to log base cos x of sin x. So from this logarithmic equation, we have to put the condition for sin x and cos x. First of all, we easily to see that the sin x and cos x have to be greater than 0. And we know that the trigonometric function is always have smaller or equal to 1. But in this equation, if sin x equal to 1, then this on the left side, this will be equal to 1. And log cos x of 1, then cos x equal to 1. And sin x also equal to 1. That's impossible. So it means sin x and cos x have to be smaller than 1. Finally, we have the condition of sin x and cos x is between 0 and 1. Okay, let's move to the next step. We have I equal to log base sin x of cos x and equal to log base cos x of sin x. Then we have the system equation that sin x power of 8 equal to cos x and cos x power of 8 equal to sin x. From the system equation 1, the first of the equation we have sin x power of 8 squared equal to cos x power of 8. And now we see we can replace the sin x of the second equation into the cos x power of 8 in the first equation. Then we have sin x power of 8 squared equal to sin x. Now we factorize this equation. We have sin x multiplied by sin x power of 8 squared minus 1 equal to 0. We know that sin x is greater than 0, so it cannot equal to 0. So the only possible thing here is sin x power of 8 squared minus 1 equal to 1. And as the condition sin x is smaller than 1, so sin x cannot equal to 1. So in this case, a square minus 1 has to be equal to 0. Then a square equal to 1. And if a equal to 1, then a will be equal to 1 or a equal to negative 1. And we replace it back to the equation. We have log base sin x of cos x equal to 1. Then we have sin x equal to cos x. And for This equation, this is a very basic equation. We already know that this will equal to sin x minus cosine x and equal to 0. Then it will sin x minus pi over 4 equal to 0. Then we will have the x equal to pi over 4 plus k2 pi, or x equal to pi over 4 plus pi plus k2 pi. However, we don't receive the second root here because if the sin x greater than 0, it means the sin x of this value is smaller than 0, so we don't receive it. So we just receive the first one. So then we have the root of the equation is x equal to pi over 4 plus k2 pi. So for the case that a equal to -1, so it means log base sin x cosine x equal to -1. Then sin x multiplied by cosine x will be equal to 1. And we have the sin x minus cosine x square equal to cosine x square plus sin x square minus 2 sin x cosine x. And this is greater or equal than 0, and this is equal to 1. It means the product of sin x and cosine x is always smaller or equal to 1 over 2. It means this equation is impossible, so we don't have the root of this case. So the final result of the equation is x equal to pi over 4 plus k2 pi, with k is the member of integers. So the lesson of the problem today is about we put the condition of the variable. It is very important. It helps us to eliminate the factor that cannot be equal to 0. And also it helps us for later transformation. For example, we remove this root because the condition sin x and cos x greater than 0. So I think it will help you in your examination. Thanks for watching. See you later. Bye.